Hey guys, so I figured after class yesterday, some of us could use a different approach or different way to look at this. So I sat down and tried to think about what was another way we could do this that would make it a little bit more structured, especially if you're struggling with how to do it when we have to multiply through by a constant. So this is a different approach to u substitution. This will work, but there's just some algebra things we need to be careful with here. So let's say I'm starting with this integral here and I want to integrate this, right? I see this isn't just a straight antiderivative. I'm going to use u substitution. So first I'm going to choose my u, and in this particular case I'm going to choose x squared minus 1 because I see that that is all being raised to the fourth, right? That quantity is to the fourth. So I see that's an inside function. I also see that this power is x squared and this power is x to the first. So that is going to be a multiple of the derivative, right? The derivative of x squared should have x to the first in it. So that's what I'm going to choose. Then I'm going to find du. So the derivative of u would be 2x dx. And instead of multiplying by a constant here, which is what we did yesterday, I am going to instead try to solve for dx. So this is the change in what we did, okay? So dx here, if du is 2x dx, divide both sides by 1 over or by 2x, and so dx would be 1 over 2x du. Okay, so that comes directly from this. So this is where we need to be careful. Now what we're going to do is just do some substitution and some simplification. Notice on all of these, I am not writing an integral because we are just doing algebra here. This is not correct notation to put into an integral. So it's going to be off to the side if you're going to do it this way, and I'll show you what we do. So this is what we started with. I'm going to start by replacing my u. So I know that u is x squared minus 1, so this is going to be 3x u to the fourth dx. So all I did was replace that right there. Then I'm going to replace my dx because I solved for that. So dx I will replace with 1 over 2x du. And then we're going to simplify, and this is going to simplify down so that we don't have any more x's in there. So I have 3x over here, I have 1 over 2x there. The x's can cancel, and so I wind up with just 3 over 2 u to the fourth du. Now I can integrate this. So now I'm going to do the integral of 3 over 2 u to the fourth. That constant can just come out to the front. So it's 3 over 2 times the integral of u to the fourth du. The integral of u to the fourth is 1/5 u to the fifth plus c. And make sure you're multiplying by that 3 over 2. So it's 3/10. Replace u back into your equation. And so this would be your final answer. It's the same thing I would get using the other way, but this approach just kind of breaks down the algebra more step by step for you. So I'm going to do 4 more examples. If you like the other way, keep doing it. But if this way helps you, I just wanted to give you guys another approach if you needed it. Okay? So the next one we're going to look at is this one. So integral of cosine x over 2 dx. So this is my innermost part. So I'm going to make that my u. And I'm going to always rewrite something like this as 1/2 x. So du here is just 1/2 dx. And I know that this is the correct u because this is just a constant. And remember there's an unwritten 1 right there, and that's just a constant. So I know my derivative is in there. So now I'm going to solve for dx. So dx equals, multiply both sides by 2 du. And now let's substitute. So this would be cosine of u dx, which is the same as cosine of u times 2 du. So this is going to be the integral of that. Plug that in there. I'm going to just bring the 2 out front. So it's cosine of u du. What has a derivative of cosine? Sine does, so this would be 2 sine of u plus c, which is 2 sine of x over 2 plus c. So just a different approach, we get the same result. All right, let's do one that's a little more complicated. I'm going to go down to this one. So this is inside my radical. My guess is that will be my u, but this is x to the third. This is x squared. That is a multiple of the derivative, so that's how I know I'm right. So u here is 3x cubed minus 1. So now we're going to find our du. That's going to be 9x squared dx. And I'm going to solve that for dx. So dx is 1 over 9x squared du. So now is the point where we can simplify. And again, this is not proper calculus notation to mix our u's and our x's. So I'm going to just do this off to the side with no integral. So this will be 6x squared, the square root of u dx, which is 6x squared, square root of u times 1 over 9x squared du. So I'm plugging in d for dx, that expression. And now we can simplify a little bit. So the x squareds cancel out. 6 over 9 is 2/3. So coming up here, this is really going to be 2/3 the integral of the square root of u, which I'm going to write as u to the 1/2, du. So that integral, 2/3, I'm going to go up 1 power with that. So this is to the 3 over 2. And I need another 2/3 out front here to make that 3 over 2 cancel. So this one is just copied down, and then this is my actual integral plus c. So that's 4/9 times 3x cubed minus 1 to the 3 over 2 plus c. Okay, next one I'm actually going to skip down to this one, and then we'll go back up. So integral of sine x over 4 minus cos x cubed. I see that this whole quantity is being cubed. That automatically makes me think, hey, this is probably going to be my u. So u equals 4 minus cos x, which makes my du equal to sine x dx. Solve that for dx. So that would be 1 over sine x du. And then we're going to substitute. So this is going to be sine x over u cubed dx, which is sine x over u cubed times 1 over sine x du. And this is the beauty of this method. These cancel out, and now I know my integral here is just the integral of 1 over u to the third du. That is the integral of u to the negative third du. And we're going to go up 1 power, so u to the negative second, multiply by the reciprocal out front, plus c. So this is negative 1/2 times 4 minus cos x to the negative second plus c. So that makes it a little bit easier, I think. Okay, last example is this one. So I see that this is under a radical. I also see that this is x squared, that's x to the first. So that gives me a hint that the highlighted in green will be my u. So u here is going to be x squared plus 10x plus 4, which makes du equal to 2x plus 10 times dx. Now I'm going to isolate dx, so 1 over 2x plus 10 times du equals dx. And then we're going to do some simplifying. So this is going to be, again, not in an integral because this is not proper notation to mix my variables. So I'm going to have 3x plus 15 times square root of u dx, which is 3x plus 15, square root of u times 1 over 2x plus 10 du. Now, simplifying this down, here's what we need to see. This is 3 times x plus 5. This is 2 times x plus 5. So the x plus 5s can cancel each other out. So what I'm left with is 3 over 2, that's this over that, times the integral of the square root of u du. Now integrating out the 3 over 2, I'm just going to bring down. This is going to be u to the 3 over 2, go up an exponent, multiply by the reciprocal out front, plus c. These cancel out, which is super nice. So I just wind up with u to the 3 over 2 plus c, which is x squared plus 10x plus 4 to the 3 over 2 plus c. So hopefully this method makes a little bit more sense if you felt like you were getting stuck yesterday. We will keep practicing this. This isn't going away. But send me some feedback on this. Did you think this was easier? Did this help? And otherwise, plan that we will practice some more in class. I know this was tough, especially on a morning when you just wanted to be in bed or studying for other tests. But I will see you guys on Monday, and we'll make sure that you're set on this, okay? Good luck on the rest of your tests, and I will see you guys next week.